You need to learn the differential equation, and you need to learn the, ooh, I'm missing a very important part down here, even though it's right. There you go. Y equals. No. The plus C is way back here. Oh, just kidding. So, Leis minus Licht, the differential equation, and there's going to be one more form of him, and the final. We're just going to play around with, oh, so we're not really supposed to solve that differential equation every time. No. Could you? Yes. Would you want to? Probably not. And you don't need to, because Leis minus Licht is all you need. But before we go any more into Leis minus Licht and logistic growth and how and what kind of tricks we can learn, ooh, we're getting there. Do you guys have any partial fraction-y, beginning of homework integral, whether or not partial fraction-y questions that you want to ask me before break? Which after break, you're supposed to have all the sections, 7.1 to 7.5, totally attempted, probably your review attempted as well, so that we can go over any questions on Monday and test on Tuesday. Uh-oh. Anything you guys want to ask me? Oh, hi. It's Friday, so I'm good. Anything else? I did have to kind of move my car to the student parking lot this morning because I forgot Grandparents' Day. Number 20. Sorry, you guys already answered this and I forgot. What page is homework on? 375. Yeah, keep answering while I get there. Oh, look, there he is. Well, remember how that one yesterday, how I started to kind of manipulate it and be like, is there another way to solve? That's kind of where it was going. And that partial fractions breaks it down into different or separate pieces. Oh, we probably go to 376, huh? Partial fractions is not the only way. Oh, that worked. Without using the technique of partial fractions. And this is where my creative, because I actually asked you guys some that you didn't like. That one day we were in our groups and you were on the whiteboards. I gave you one that could have been solved with partial fractions. But you didn't know. So you were doing creative U sub. So with creative U sub, you can look at this guy. Oh, actually, he's kind of nice. I mean, he's really nice. I gave you a messier one than this because you're... My U prime's right there waiting to go. When does it get bad? Nothing crazy. No. Nothing crazy. Nothing crazy. And remember, this is a good technique for integration because you guys are seeing harder ones now, right? Okay. Ooh, that was a good one. Wait. Oh! I like 22. He's a great example. And he's an even, so you guys don't know if you actually did it right or not, unless you checked on Slater or something and hoped that Slater was actually right for once. What should you do? Yeah. Come on, my long division people. Why long divide? It's not heavy. So throw that 2x cubed in and just simplify that improper fraction. Yeah. Oh, I don't know. It's 22. No, I don't think so. Debate. Oh, lo siento. I meant like go through the section. I didn't have the homework numbers when I first looked at them. So I was like, oh, 22, and I didn't look to see what the... But 22 is a great question. Isn't it just long division? Doesn't say no long division, it just says no partial fraction.
And then use integration on crack and solve for x squared. Sorry.
Yeah. Oh, the 2's gone too.
I did heart method.
Oh, yeah, that works.
2 over U.
Which is what eventually I probably would have gotten. Does that make sense? And then, but yeah, that is pretty good. Because see, what I'm going to be getting is a 2x minus, plus 2x over x squared minus 1. That's what long division would get me, I think, right? Minus a negative is a positive. Yeah. So then when I go to integrate, I'm going to have an x squared, and you're going to have a u x squared. Ooh. Also, but our constants are going to be different.
I got x squared minus 1 plus ln of,
But mine says, hey, minus 1 and plus c, whatever, it's a new plus c. But it's the same answer otherwise. You should absorb it into the plus c. Because that means the way that you solved it, there's an extra constant. Which if this was like a response and you were solving a differential equation, because otherwise make it match. But if it's a free response, when you go to find your plus c, because they'll give you a point, you'll put it together with the minus 1 anyway, or you'll leave it unsimplified and you'll be fine. So it's not really something to stress about though, Maggie. Anyway. Lo siento that I confused you all. Up to 20 was technically like the last homework problem you could do in this section from 1 to 22. Unless you, Justin, congratulations, kept going. What do you guys see about each of these? Is there an LK? No, KY times L minus Y? Wait, who's Y though? Oh, P. Oh, but P is Y. Oh, that makes sense. Maybe we should go figure out what those formulas are and how to use them before we start trying to figure out gorilla populations. Okay, so the beginning of your packet. Have your notes still there, packet. Sorry, no one else said anything, but I apologize. Any more integration from last night we got stuck on? Okay. Why logistic growth? Many things that grow exponentially cannot continue to do so. Truth. This is a good thing. The human population checked would have people covering every square inch of the Earth, then the galaxy, then the universe. Yeah, okay. After a while, to start off growing exponentially, begin to compete for resources like food, water, money, and parking spaces. Ever heard about a sustainable population? What's sustainable population mean?
Population that can survive using its resources without having to reach demand for the environment.
Because right now we're able to ship resources to where we need them as long as we have money, pretty much, right? We're able to bring resources in. But imagine if we were just living off the land like a lot of animals do in different populations, there's going to be some sort of limiting as to how much we can grow, right? Because if it grows, or if we grow too fast, either things will start starving, or if we're talking about like animal populations, the predators are like, oh, we're going there because that's where all the elk are, that's where all the deer are, that's where all the, go to Colorado. Or is it back east, there's a huge, and it's a strong one, so the hunting licenses where you can kill as many as you want, just to try to limit how many are there. Or up in Alaska, it's a very similar thing. So depending on the environment, there's usually some sort of sustainable population, either before predators come and it kind of balances out. Circle of life. Anyway, so coming back. The growth begins to taper off as it approaches some carrying capacity. Carrying capacity, limiting capacity, upper limit, L. Lice minus lick, that L. KY times L minus Y, that L. Is the horizontal asymptote as x goes to infinity? Yes. Is the carrying capacity of something like a population beyond which it probably won't grow? Yes. Okay. They also use the example of a rumor spreading through a school of 2,000 people. It could start exponentially, but what's it going to eventually do? You guys know this with memes and everything, right? Oh, it's so funny, and then what's it do? Tapers off, loses popularity. Or in our case with the rumor, there aren't as many people to tell. Everyone's heard it. Minus maybe the few that just don't really care and won't ever be a part of it. Right? Right? So logistic growth can be, used in so many different ways. We already did this, so go ahead and just do a little check as long as you wrote it in your notes and keep going. Ha-ha, Lice minus licked. Lice minus licked. The reason why I did that weird dividing by that CE to the LKT, even though it put a really weird, like, complex fraction in, is because L is isolated, which is exactly what we want, because it's really cool to look at some sort of population equation or amount equation and say that's the carrying capacity. And the nice thing is that's how the AP gives it to you. So you can look and say, as long as it fits lice minus licked, haha, L is that top horizontal asymptote. However, there are some really important clues down here. If you're a highlighting kind of person, maybe grab out a highlighter. If you're I'm going to steal those and put them in my notes, that's also a great idea, and we'll talk about it in a second. But here's the really cool clues down below. First of all, L, yeah, super important, the carrying capacity, or I'm going to call it the limit, the limiting capacity also. So you can take a limit to infinity of a legitimate. This goes to infinity, that goes to 0. Because it's 1 over, right? E growing, growing, growing. So then L would be your limit to infinity. But you can also just say, well, I know the limit. Duh, it's right there. But here's the other important part. Increasing most rapidly. Look at your equation. Or I should say, look at your logistic growth formula on the first page. Increasing most rapidly. Increasing, that's looking at slope, right? Most rapidly, isn't it looking for the max slope? Where's the max slope? At the point of inflection. Look, check out the graph, right? The point of inflection. That's when it's growing the fastest. Because before then, it's building up to that, and then after then, well, it's tapering out. True? The point of inflection, concave up to concave down, is going to be, oh, we have to find the point of inflection every time, the second derivative? Pause. What's the really cool clue? For logistic growth, the point of inflection will always occur halfway. So if that's L, it's always going to occur at L over 2. Now that's awkward because we know the Y value, and they're always asking for the X. But it's cool too, because if you have your lice minus licked, you can just set it equal to half of the limiting capacity, and that is going to be your point of inflection every time, unless your population starts above the point of inflection. But then there wouldn't be a time where it could possibly equal.
I was just going to ask if that's true for every logistic growth. The maximum rate occurs at capacity.
Every logistic growth where the population starts below L over 2. Even if it starts at L over 2, that would still be the highest growth. It's just awkward. If you're starting your analysis partway through. Does that make sense? Okay. So let's take all of these important things and make an endeavor card out of it. P.S. One of the things this break, you guys are used to breaks in AP Calculus homework, right? What do we almost always do every break? Forever. But we've gotten kind of disorganized, yeah? So here's what we're going to do. After break, the Monday after break, and I'm going to make a Google Classroom assignment for you guys. Class notes online. Are we tracking? Okay. Forever's Endeavors will be updated up through logistic growth in the Forever's Endeavors online. And you guys need to have here in class Endeavors updated to go. Being okay, here we're organized, we have it all ready to go. We're not going to have Forever Endeavors on Monday, even though there are some important things to memorize for this test. So it's not everything crazy. Trying to see the things that are particular from the chapter that you grow. We're not making a forever skill from the So no, all of us on the same page in the semester and being able to start off second semester. Is that? There is going to be a forever endeavor final though. So we need to organize for that. Cool? Mm-hmm. Mm-hmm. That's final though, that's final. It'll be, you guys know that last week right before finals start, probably around the Thursday, Wednesday, something like that. Exactly, so you're updating your cards, it's perfect. Today's the 16th. Karen's birthday. Okay, I told you there are two forms to the differential equation. So I need to write both forms, okay? Here's the other form. Careful, 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 careful. Adding. I'm adding something. An additional topic, an additional piece of information, I should say. What happens? Richmond just stole them, huh?
Collecting the OCC boxes.
L. Y. 1 minus. That's gross, I know, but it's right. Wait. If they give it to me like this, can I make it like that? Maybe. If they give it to you like that, can you make it like that? Maybe. What did I do to get from here to here? I factored out an L. And when you factor out an L, you divide. So that one, divide it clean away. That one, it was. So depending on how they give you the differential equation, L could appear different places. Does that make sense? Why didn't I underline this L? Isn't he a constant and he a constant, and it's going to be multiplied to be a new constant? That's going to be grouped together. We're not going to see the L clearly. Where are we going to see the L clearly? I can see clearly now, right there. It's never really come. Maybe it's still coming. So I have an L there, I have an L there, I have an L there. I have, a limit that's an L. And then I have an increasing fastest at. Oh, man. Most common mistake. Everything. They're going to ask you for the time, almost always for the value, but what an easy question. L over 2. They're usually going to ask you for time, so you have to take y equal to L over 2. But as we just saw in the book, it wasn't y's. Weren't they p's? What were the p's standing for? Population. Isn't population just y? Y is how many is left over? In finances, wasn't it A for A equals P times E to the RT, PERT? Anyway, the variables can change. The ideas do not. Here we go. Packet. Y. I didn't want you guys to waste time writing stuff down. Packet. Here we go. The population of Alaska. Since from, awkward. Ignore that. 90,000. Modeled by the following logistic equation. Interesting. Where P is the population, T is T years after 1900. What is the predicted population of Alaska in 2020? We might not go to our calculators for everything. Is that okay? We're just making sure we can do it. So write down an expression that would solve for what A is asking. P is population, T is time, years since 1900. Letter A is just asking for, what is the predicted population of Alaska in 2020? Yeah, it was that easy. What'd you guys do? Why 120? Years since 1900. So 2020 minus 1900. Does that make sense? Oh, it's okay. What? 30 would make sense if 1990. Pause. Letter B. How fast was the population of Alaska? Oh, I have to derive that? There's an endeavor card that tells you what the differential equation will always be. So hold on, check. Can't we call this a lice minus licht? What's the differential equation then going to be? Oh, it's going to be dp dt, right? We've got to make it particular to the problem. Ky, wait, y is who? Oh, sorry. I just meant p in this case. Does that make sense? ky, well, it's really a p. And then L minus p. Is that okay? Ky, L minus y, but y is a p. Can you guys make the differential equation without having to derive that guy? Okay, so who's L? Oh, that guy. Okay, so for letter B, I could go ahead and say, I'm going to do P prime. Yeah, you can plug in the numbers 20, 40, 99. But I have 8, 9, 5, 5, 9, 8 minus P. Who's K? What is that? Yeah, it's not a big deal though, right? Can't I just steal this and say that he equals L times K? So can't I just say that K is equal to this guy divided by L, which we could totally do because we know who L is? Does that make sense? Now, could you take the derivative with like a quotient rule? Sure. I mean, could you make it this to the negative 1 power? Sure, you could. You could take a derivative. Wait, if this is a calculator problem, couldn't you just do the derivative in the calculator and plug in? Wait, can you? Pause. What's the difference between making the differential equation this way and solving for it outright this way? That's the problem. If you solve for this derivative by hand, couldn't you just plug in t is 20, t is 40, t is 99? Who's this asking for? P of t. Oh. So if this is a calculator problem, you could just do your n derive, right? It's nasty numbers, it probably will be. So you could just do n derive at 20, at 40, at 99. But if you were trying to make a differential equation, you're going to have to do p of 20, p of 40, p of 99. The difference between our differential equation clue is it's implicitly dependent on the y's or the p's, whereas this equation is dependent on t's. Just be careful. If you want to go this direction, you can't plug in 20, 40, 99 immediately. You have to plug it into p's and then plug in. Does that make sense? Okay. So showing you the idea of, yes, you can go from lice minus licht to the differential equation. Is it really helpful? It depends. Letter C. What's it being asked there? Maximum derivative, right? Growing the fastest. That's not the highest population. That's growing the fastest. The highest population is this guy, right? Yeah, you're going to have to set this guy equal to half of 895,598. But once you get that number, can't you set it equal to and then solve? Oh, I don't want to solve. I'm in a graph. Are you really 895? If you want to, go ahead. Sure, you can make your window. Maybe. You could graph L over 2 and you could graph this guy with a window of, you know how high he goes. Make him 1,000,000, right? Make your Y max 1,000,000, and then you'll see your logistic growth. You'll see your L over 2. The only thing you might have to change is how many years. But you kind of have an idea of that too. Have your years go to 20. To play with your zooms a little bit when practice using your calculators. That's okay. But you're going to have to play with your zooms. But remember, he's the highest your Y goes, and they should give you some idea with the X's. What's going on letter D?
The maximum population is L.
The maximum population is L. Be careful what some of you guys were saying. It's not actually, the population isn't necessarily decreasing if it's logistic growth. It's just going to slow down on its increasing. Does that make sense? It's going to slow down on its increasing. According to this model, if it is still displaying logistic growth, which maybe it's not. it kind of makes sense that maybe the population of Alaska is decreasing, though? I don't know if I would agree with that.
Why is those so low? Why is the maximum population of Alaska so small?
A lot of Alaska is inhabitable. So it does have big cities, and those are growing. But this was back in 2000. A lot could change, so I don't even pretend to know what's going on now. I don't know. Sarah Palin, everyone ran away. That was where, Maggie, that's where your parents went, right? Juneau? Yeah. I want to visit Alaska. It seems fun. But
There's literally nothing to do there. I've been there.
I have a friend that lives up there.
My dad tells me that a lot of people get drunk in Alaska because that's the only thing there is to do.
It's true. Well, and unsavory things that you probably shouldn't be at.
I had a king crab leg.
Oh,
Dude, that was
yeah.
so good.
I have a friend who lives up there, and she would be like, "Oh yeah, it's going home from work," and she was just biking. I'm like, "How do you bike?" And she's like, "It's light outside." Like, but then it's dark out like the other.
It's really like they're zip lining. We have zip lining in the rainforest. That's cool.
Hey guys, guess what? Love you all. Example 7. Okay. Example 7. Oh, what's different? What's different? They gave you the derivative. Aw, where's L? It's 100. Oh, that's easy. 100 bears. Duh, bears. Is that too old for you guys? There's some edumacation going on over here, but hold on, focus.
But you're going to college.
He wants to go to Idaho.
Maybe after grad school.
I'll get you. See where you are.
That,
Come to my mansion.
Where are you going, Tennessee? Idaho. Yeah.
yeah, I'm sure they have nice rivers.
My friend works in that's like 2 hours out north of there. Here we go. Population growing fastest.
L is 1/2.
What are they asking for? Oh, 50 bears. Duh, bears. That's easy.
This is easy. I can do this one.
What is the rate of change? Wait, what are they asking for?
They're asking for T. They're asking for DT. I don't know. Forget it.
You guys know rate of change, right? dp dt. Such that, oh no, we need to go plug in and find t. Do you?
You just plug in.
Don't you just need the population? Bears per. Ah, we didn't even have to go to lice minus licked, but if we did, I guess we could have. We didn't even have to go to lice minus licked, but I guess if we needed to, we could have. Because isn't that the K if we end up needing to go there? We have the K, we have the L.
With 3 minutes left.
Wow, Arya, you missed so much.
Thank you.
Arya, so disrespectful.
What about this one? Wait a minute, this is not what we're used to. It's okay, what do you do? We want it factored, yeah? Ooh, we're factoring out a P, but what else are we going to factor? Why am I going to do a 0.002? Which one do I want to be 1?
The L.
I want this guy to be 1. I want him to be 1, because if he's 1, who's this? If he's 1, then I'll have my L. So remember, when you factor out, you divide. That'll just be 1. But this one, you divide. Well, isn't there 100 in between? Right? 2 decimals. Oh, L's 100. Could you have factored that guy out? Yes, but it wouldn't have been in the right form. you could have factored out 0.2. And if you had had that, you would have had 1 minus 0.001, 0.01, which would have been 1 over 100p. Could you guys have seen the L fully? So it's up to you. The L can show up either way. You just have to be able to be looking for it. Does that make sense, kind of? What's going on over here? Limit to infinity. If you start off with 5, is that lower than half of 100? Oh, so what's the limit? 100. If you start off at 60, oh, it's over that halfway point. So I guess technically the steepest slope will still be at the beginning, but it's going to be diminishing everywhere after that. But the limit's still 100. Wait, what if you start off with more? What's going to happen? It's still 100, just you're going to have stuff dying off because it's too big for what the environment can handle. Does that make sense? Which one has an inflection point? Didn't we talk about? We have 100, and the inflection point should happen at 50. This guy will have an inflection point. This guy will not. And this guy, well, he won't either. Pause, pause, pause. Does it make sense? This guy will have an inflection point because he's going to 50. He's going to be increasing and then decreasing for the growth rate. For the growth rate, not the population. This guy, he's already starting above the fastest population growth, or the point at which the population would be growing the fastest. So he's not going to change. And he is. I already lost you guys, didn't I? What's your job? You guys have a homework. Issa, Riley, focus. You guys have your homework in your book, 7.5, but some of you are already done. Don't know how that happened, but some of you are halfway done. You guys have, did the bell not ring? Some of you guys still need to catch up on notes, need to catch up, everybody, on Forever's Endeavors and have them Monday, but what else? Play around with partial fractions and logistic and show me that you know it. Bye, guys. See you later. Oh, just finish it. It'll be for the homework spiral day of the test. Yeah, they're in the back. They're not blue, they're white now. This is for